Well, hello and welcome. My name is Morgan Kessler, and I'm a civil engineer at the Federal Highway Administration's Turner Fairbank Highway Research Center in McLean, Virginia, and I'll be your moderator for today. I lead a range of research efforts here at Turner Fairbank, mainly in the advanced digital infrastructure realm, and this includes work having to do with how automated vehicles interact with the highway infrastructure environment. Today, I'm excited to kick off this webinar from a recent research project that we're just wrapping up, and it's titled Automated Vehicle Readiness, Funding and Timing Challenges for Infrastructure. And you'll see in the title slide there, this webinar today it's focused on roadway markings, and we'll be talking more about that in a little bit. But for some background and context, this project was born out of an earlier Federal Highways research project called AV Impacts to Highway Infrastructure, and that was finished and published around 2021. Basically, it was identified in the report that there was an immediate need to address two common DOT concerns that consistently rose to the top. These were one, funding concerns related to new and/or additional requirements associated with automated vehicle use, and the second was understanding the timing horizon associated with these changes. So based on the current state of knowledge, including the research documented in the first Federal Highways report I just mentioned, pavement markings stood out as one of the most important infrastructure needs for today's partial, SAE level 2 vehicles, as well as the more capable AVs of the future, and that being SAE levels 3 through 5. But if these pavement marking assets require a system-wide update and higher maintenance standards, what is the best approach to optimize such investments? Another way to state that would be how much and when. So those questions led us to the work we're talking about today, the research project we're talking about today. This project was contracted and was done by Applied Research Associates with their primary project manager being Jason Bittner. The PI for the project is Dr. Paul Carlson of Roadway Infrastructure Incorporated, and I'm about to introduce them in a little bit. So being a Federal Highways project, we have to include this disclaimer. And essentially what it says is the U.S. government does not endorse products or manufacturers. And if you see, like name brand products or manufacturers in this presentation, it's only for informational purposes only. And we're not saying this is what you want or need to use. It's just for illustrative purposes. The other thing the disclaimer says is that this presentation was created by contracted experts, and they're going to have their opinions based on the research that they did, and those opinions don't necessarily reflect Federal Highway Administration's stance, and they shouldn't be construed as direction or guidance or anything like that. So I'll just wrap up by saying today's presentation is intended to be interactive, and if you have any questions, please type them in the Q&A pod. We'll hopefully have time at the end to go over these questions and get some good feedback from Jason and Paul. So without further delay, I'd like to introduce Jason and Paul. First, Jason Bittner is a principal with Applied Research Associates. He currently is working with SAE International on a series of EDGE reports looking at infrastructure enablers for automated vehicle technologies. He has worked on AV readiness planning research for TRB's Forum on Automated Vehicles and Shared Mobility, Also, FHWA, the Tampa-Hillsborough Expressway Authority, NCHRP, the state of Missouri, and other sponsors as well. He resides in Madison, Wisconsin. Also today, we're going to have, as I said, we're going to have Paul Carlson. Paul Carlson's expertise is in the intersection between physical roadway features and automated vehicle needs based on vehicle sensor perception, as they can differ from conventional roadway users, i.e. humans. Research sponsors include FHWA, NCHRP, private industry, and international agencies. Paul leads several national efforts to develop a deeper understanding of how to adapt the highway infrastructure to support the safe deployment of automated vehicles. Paul lives in North Carolina. So with that introduction, Jason and Paul, please take it away. Looking forward to hearing this good presentation.
Great. Thank you, Morgan, and welcome everyone to today's webinar. As Morgan introduced the topic, we are happy to report on the results of a research activity that we've recently completed and are in the process of wrapping up the final products, looking at some elements as they relate to pavement markings and infrastructure readiness for automated vehicles. What is on the slide right now, and I've mentioned Jason Bittner, you'll hear from Paul in just a couple of moments on a different section of the presentation, but this presentation outline that I have up now will be a little bit about how to expect the next 45 minutes or so to go. We're going to summarize our topic and the project. We'll talk about roadway striping and machine vision, asking some of the key questions that you see there. What are the interplays? What are the strengths and weaknesses? And what is the current state of the practice with respect to roadway striping? And then dive into the cost analysis piece of it as was introduced earlier. And what are the key activities that need to be undertaken by infrastructure owners and operators right now with respect to providing that roadway striping. We'll provide our recommendations and have concluding remarks. If you are interested in asking questions, we will monitor those through the Q&A pod. Again, feel free to enter those as we go along, and we'll have an opportunity to address those at the end. I'll also point out that this session is being recorded, and the recording will be available after the event. If you have any concerns about being recorded, obviously the easiest thing to do is to not provide a question in the Q&A format. That information will be part of the package that is distributed at the end of the project. So by way of introduction, the first thing that I want to acknowledge is, as was mentioned in the introduction, Morgan had indicated that Applied Research Associates was contracted to perform some of the work on this. We've worked with two primary partners, that being Paul Carlson of Automated Roads and the team from Gannett Fleming, Lori Matkowski and Ryan Rice contributed to it. On the Applied Research Associates side, I also want to acknowledge the work of Carmen Dwyer, Neil James, and Lisa Schofield as part of our team for this project. And the project initially was set out to provide a tangible estimation of some activities that state and local agencies could take to prepare highway infrastructure for automated vehicles. And in the timeline that was introduced at the outset, this project flowed from other work, and I think it's important to discuss that in the 2019-2020 timeframe, industry and some planners were anticipating a rapid acceleration of the deployment of AV technology. Pilots by Waymo, Uber, and others seem to be dominating the news cycles, And as a result, this project was developed to put out a series of white paper topics on the costs of potential improvements and enhancements to pavement marking, some better understanding of the actual timeline for adoption using publicly available sources and focus groups with auto manufacturers, identification of the potential returns on investment, and then discussion of the context of high definition mapping or other elements that could support improved roadway marking. So those rosy projections really set the stage for how this project was initiated, and we're going to focus again today on the roadway markings element. IEC, International Data Corporation, had issued in 2020 a forecast that said that 50% of all new vehicles sold will possess some degree of automation by the 2024 model year. That number, dependent on the definition of automated vehicle technologies, if you expand it to include lane keeping assist features as well as adaptive cruise control, that target has been hit in the 23 model year. 50% of the vehicles available have that degree of automation. Our initial white papers on this subject also discuss the importance of vehicle-to-infrastructure technologies and the important part that those technologies play. Infrastructure investments obviously would need to be prioritized. The elements that are impacted by these AV developments need to be further identified and outlined as states make their investments in that roadside infrastructure. The most important finding that initial work is that, above all, pavement markings need to be readable for enhanced deployment and use of automated vehicles on the public road. Most of you on this call are likely familiar with the Society of Automotive Engineers automation levels that are displayed here from a 0 to 5 scale, ranging from no automation to full automation. In Morgan's introduction today, he mentioned that SAE International is providing a series of edge reports on unsettled issues as they relate to infrastructure. SAE also has a number of task forces and a committee on on-road automation that is also looking at elements of infrastructure and its important role in fostering the development and expansion of automated vehicle technologies. Kelly Coiner and I are the co-authors, the co-editors of that series of EDGE reports, and those are currently in development. One is focused on pavement markings. If you would like additional information on that, we can certainly provide that information as well after this presentation. The first sort of primary deliverable out of this project dealt with addressing timelines and some ground truthing on what information was being provided by auto manufacturers and component manufacturers at the time of the project. Those, again, I mentioned rosy projections. We've kind of softened some of the initial projections that seem to skew perhaps less conservative in their viewpoints on when the announcements of availability of vehicles and the use of automated vehicles in the vehicle fleet would be made. The expected timeline, a lot of announcements were made that by, this point in time, practically, the 23 model year to the 24 and 25 model years, that there would be a much greater penetration of automated vehicles in the consumer fleet. By all indications now, most of the community agrees that fully automated vehicles will be available by 2035 or later, mostly in limited use cases and in specific operating design domains. By 2040, most vehicle fleets, both commercial and passenger, will likely be partially comprised of automated vehicle technologies and shared vehicle technologies. So again, that timeline has pushed out even during the course of the completion of this project. So 2040 is likely the best estimate that we would now use for when states should expect to see a large percentage of vehicle fleet having automation as part of the fleet characteristics. Irregardless of that pushed out timeline, most state plans look well beyond 2030, 2040 into 2050 for infrastructure improvements and sequencing of investments. So the important takeaway is that planning and infrastructure decisions for these automated technologies, even with that extended timeline, do need to be made now. And what can states do right away to help encourage that? What can states do as these technologies come online? And we're going to focus on the pavement markings piece of it as we go along. We also included in some of the initial research a current snapshot of sensor technologies that were available, understanding how sensors are used to help navigate the roads. Sensors used alone provide that SAE level 0, level 1 driver support systems, automated driver assistance systems. It takes additional technology and additional machine vision or other applications to truly be integrated into a level 2 or a level 3 automation. The further advancement to level 4 or level 5 automation requires the integration of additional technologies as well. So AVs do navigate through the use of a variety of sensors and camera-based technologies now in the pilot applications and pilot deployments that you see out there. The use of sensors in general by themselves, though, do not have a defined role in the level 0, level 1 sort of driver support beyond just communicating information to the driver. It's the further advanced levels of sensor technology that we defined in the white paper. Machine vision is the technology that has been used to sense pavement markings, providing inexpensive ways to provide lane departure warnings and lane keeping assistance capabilities, allowing either further vehicle perception of road signs, traffic lights, roadway markings through the use of machine vision. Of course, we will also address some of the gaps and some of the weaknesses of these technologies. They are dependent on environmental conditions and other machine learning as they experience edge cases. Machine vision cameras used in ADAS systems rely primarily on pavement markings to perform several of their functions. And hence, with that introduction, I do want to turn it over to Paul Carlson at this time, and Paul will talk us through some of the findings of our work related to the pavement markings piece.
Okay. Yep. Thank you, Jason. Please let me know if you cannot hear me or give me a sign, Jason.
You're good.
So, thank you. I appreciate that. As Jason said, and I think Morgan might have mentioned this early in the project, this project was sort of a follow-up from a broader scope project where pavement markings were identified as a potential need for additional research and understanding. And so that's one of the areas we emphasize in this project, and you'll hear more about markings as we move on because of that. So obviously road markings have been around for 100 years, introduced on horizontal curves over 100 years ago to keep drivers safe, and they have obviously matured in their application to provide driver navigation and driver safety. And there's been a lot of work over the last 100 years to provide national guidance on applying road marking for the human need. But as we look ahead into what automated vehicles need, we're starting to understand more and more that of all the roadway features that are sort of physical, road markings are perhaps one of the most important for automated vehicles and the sensors as Jason has described. But it's a little bit of a different story in terms of what the automated vehicle needs compared to the human driver. You know, the automated vehicle industry is trying to program these so-called robots to drive the machines without situational awareness that we have as we experience driving from a passenger as a young child all the way through, you know, the transition into being a driver when we're 16 or so. And so we generate a lot of situational awareness that machine vision systems and automated vehicles don't have. So they rely more on these physical features such as road markings. And one of the things that we've come to understand is application of road markings and other traffic control devices comes under the purview of the MUTCD. And if you sit on the national committee or work with FHWA's MUTCD team for any period of time, you'll start to understand there is a challenge in that space to provide guidance, but also provide flexibility. And nobody wants a cookbook. Not every situation can be handled with a certain specification or standard. So there is a lot of flexibility in how we apply traffic control devices to the roadway systems. And if you have situational awareness as a driver, you tend not to notice those inconsistencies. But if you're trying to program a vehicle to navigate a roadway, you would love to see more consistency and more uniformity in terms of traffic control device application. And so that's really the difference here. And at the time we were working on this project, or got started on this project, FHWA was looking into revising the MUTCD, and there was discussions about how to tighten uniformity within the manual that would be good for automated vehicle deployment while also improving safety for human road, you know, the human driver as well. And so this project was sort of occurred during the transition of, this was even before the NPA was announced into the NPA. Obviously, there's not a final rule yet for those of you that are familiar with the MUTCD, but we expect one very soon. So we still don't know exactly what's going to be in that final rule, but we have some good sense from the NPA. And I think that FHWA's MUTCD team is making some strides to provide tighter uniformity in response to the needs of automated vehicles. And a lot of that happens to fall within the pavement marking sector, and we'll talk more about that as we transition through these slides and get into a little bit more details about what we learned and what we did on this project to get an understanding of what that means for the country. So let's go to the next slide, please, Jason. Okay, so now, with that segue, we'll get into a little bit more details about what I just defined and talk about the importance of automated vehicles. So let's go to the next one, Jason, slide 13. So if you dig into the research, there's a pretty significant statistic that shows that most of vehicle crashes can be traced to human error. As a matter of fact, 94%. And I've seen people challenge this number. I've seen other researchers challenge it, but it still stands to this day. So obviously, if we could eliminate some of that human error, or all of it, ideally, you know, we could make very large strides in reducing the number and maybe possibly severity of our crashes on our roadway systems. And that's one of the big promises of automated vehicles, is the improved safety. But not only that, there's many other promises of automated vehicle deployment. And accessibility, for instance. I mean, I'm seeing that firsthand. My parents are both alive, but my dad has opted to not drive anymore for good reason. He probably drove a little longer than I felt comfortable. But obviously, that is a common transition as folks begin to age. And so with automated vehicles, you can imagine accessibility increasing quite significantly for certain sectors of our population, senior citizens, people with disabilities, and so on and so forth. And then economically as well, that's another big promise of automated vehicles. The planning around congestion, you know, perhaps less levels of congestion, perhaps better use of fuel, whatever fuel system you're using. Lots of potential economic benefits as well. Obviously, CO2 emissions, if most of them go EV, and that kind of thing. So there's still lots of promises out there. We've yet to really realize any of them, at least from a scale perspective. Obviously, there's pockets of AV here and there, and there's probably some case studies in those areas, but we haven't seen it scalable yet. But when it does, and if it does become scalable, these are some significant benefits and promises that I think we're all looking forward to. And part of what we're doing here is trying to understand how can we accelerate this safe deployment of automated vehicles and see some of these potential benefits. And how can we do that through rethinking about the infrastructure and perhaps enhancing the way we design, operate, and maintain the infrastructure? Are there ways we can do that? So within a sort of a big picture, that's kind of what we're trying to do here. Okay, let's go to the next slide and talk about a little bit more of the potential benefits. So benefits from the automated vehicles obviously depend on some reliability from detection of certain infrastructure elements, such as pavement markings, for instance. We can't provide lane departure warning. We can't provide lane keep assist without some detection and reliable detection of road markings. That seems obvious. Also, our #1 crash is run off the road in the United States. And so you can imagine if we could provide good edge lines on our roadways and maintain those edge lines to whatever degree is necessary for an automated vehicle, maybe we could make a huge dent in run off the road crashes with automated vehicles as well. So there's lots of additional benefits as you drill down deeper, but it all starts with that robust detection of certain aspects. And for the types of automated features I've talked about here and crashes I've talked about here, we're talking about robust detection of pavement markings. So one of the things that we still need to understand a little bit is the maintenance of pavement markings, and how do we try to think about maintaining road markings for that robust detection in order to reduce the frequency and severity of crashes. That's still a work in progress, I would say. Obviously, the feds have, in the MUTCD, published minimum pavement marking retroreflectivity requirements for the nation. But to be clear, those are based on the visibility needs of older nighttime drivers, and it really has nothing to do with automated vehicle or machine vision systems. So in a way, you could think about that as step one. Step two might be, for instance, another set of conditions where if an agency wanted to, or they would at least have some information that they could use to say, you know what, I want to make sure my interstates not only meet the needs of nighttime older drivers, but also meet the needs of automated vehicles. There might be a different set of pavement marking criteria for that. And how that would look compared to what's already in the MUTCD is yet to be understood fully. And that, like I said, work is ongoing to understand what that would look like, but it wasn't necessarily part of what we tried to do here. What we did try to do, though, was try to understand, at the time, we knew that FHWA was leaning towards changing some standards in the MUTCD regarding pavement marking width, again, to support AV deployment, but also to increase safety for the traditional road user, i.e. the driver. And so we did do a little digging into what that would look like in terms of a cost estimate across the country. So maybe we could go on to that a little bit. Let's take a little deeper dive into that one. So this is where we talk about the cost analysis. I just teed that up. So at the time when we were doing this project, it wasn't 100% clear where the FHWA might go with their rulemaking. And so we actually conducted sort of two different levels of assessment here. One would be if the MUTCD were to say, you know what, we want, instead of 4-inch pavement, instead of a minimum of 4-inch pavement markings across the country, they went to a standard of 6-inch pavement markings across the country. What would that look like in terms of a national cost? And at the time, there was some uncertainty about where the threshold would be based on speed. Would it be based on all roads, greater than, with a posted speed limit of greater than 50 miles an hour, or would it be 40 miles per hour? Where would be the threshold that FHWA would draw the line? Well, they ended up drawing the line at 40, as indicated in the first bullet there. So right now, that's the proposed recommendation that FHWA has. It's not in a final rule yet, so it actually hasn't happened yet. But I think there's a lot of people anticipating that the road marking width for longitudinal lines, center lines, lane lines, and edge lines will become 6 inches for roads at 40 and above. And then there are some exemptions to that were posted in the NTA, but we're not going to go into details here. We're just going to sort of go with that general statement for now. And in order to put together a national assessment, we relied on a lot of previous research. So previous research very recently had recommended or had done some nationwide surveys and determined that waterborne paint was so much, not only to buy, but to install. Thermoplastic was a little bit more, and multi-component materials were even more than that. And the percentage of roadways that fell into each classification with some major assumptions, to put it lightly. It's very hard to really kind of put this down in a analysis where you know where all the waterborne paint is, all the thermoplastic paint is, and all the multi-component. But in general, through state specs, we have a good feel for that in northern versus southern climates, where in the northern more waterborne paint is used, and in the southern climates more of the durable materials are used. We were able to make some pretty good assumptions about distribution of material type. And obviously, so when you go to costs, that third major bullet on this slide, there's an increased material cost because you're essentially going from 4-inch to 6-inch material. But we also, in talking to applicators around the country, realized that there will be some production reductions in terms of, hey, if I'm going to have to put down a wider line, a 6-inch line instead of a 4-inch line, the pumps on the truck might not have been designed for that, or at least to go the speed that I can put down paint with a 4-inch line. I probably will have to slow down a little bit to put a 6-inch line down in order to put enough material on the road to meet the spec, to hold the reflective beads. And so through some conversations with some experts in that space, we came up with an overall 10% reduction in production in terms of application of product. Also, it will require, if we're putting down a little bit more material, paint trucks will have to stop a little bit more frequently to refill. Thermoplastic trucks will need, if they're used, depending on how they're loaded, a lot of them are loaded with a supply truck that's already melted the thermoplastic. They'll have to stop and reload more often as well. So we went ahead with an assumption across the board of a 10% slower application rate. And I think those are some of our major assumptions going into that. Then the next thing we needed to do was understand which states are already using 6-inch materials, which states are using 6-inch materials in some places, and which ones are not using 6-inch at all, so that we could break up the national mileage and get a little bit more accurate description of what it would take. So in this slide right here, states that are shown in white generally are using wider markings for these types of roadways, 40 and above. And states that are shown in blue are not using 6-inch markings. So it's sort of a mixed bag, but if you were to look at this graph over a period of 10 or 20 years, one of the things you would immediately notice is the country is already using, and there's already a trend to use 6-inch wide pavement markings across the country. So this isn't something new, and as a matter of fact, as you can see from this slide, it really only impacts probably half of the states, but how it impacts each state is different depending on how they're doing 6-inch markings, how many miles they maintain, and those sorts of conditions. Okay, so now let's talk about the final numbers that we came up with. So we did all of this analysis. We pulled together, roadway mileage, lane mileage. We tried to layer on where 6-inch lines were, where they weren't. We came up with an estimate for all state roads. If you were going to convert them overnight for speed limits 40 and greater, you're looking at a $400 million endeavor. Obviously, a little bit less if you change the speed threshold because you have fewer miles that you have to move from 4 to 6. But these are initial findings. And again, they consider the different material types, they consider the different specs states are already doing and applications they might already have, with some other assumptions, obviously, that application speeds will be reduced by 10% and those types of general assumptions. Obviously, not every applicator will have to slow down. And states like Florida have been using 6-inch pavement markings for 20 years. Michigan has as well. So many states really have zero impact from this potential change. Others have some catch up to do. So let's go to the next slide and break this down a little bit more, because most of the conditions like this in the MUTCD, there's a compliance period. So you don't necessarily have to change over your traffic control device provisions overnight. You've got time to do that. And in general, 4 years is sort of a good rule of thumb. So if you were to just say annualized over a 4-year period, what would this cost the nation? You're talking about, if it is a 40-mile-an-hour threshold, we're talking about $140 million a year for the country, which, you know, that hopefully that doesn't sound like a lot of money to anybody if you're in the highway space, because it's not. It wouldn't even be a lot of money to large states, but this is across the country what it would cost over a 4-year period. So we're talking about a very insignificant impact to maintenance dollars, or wherever the money might come from. It varies depending on the agency type, but relatively small numbers to support the safe deployment of automated vehicles and improve run off the road crashes and severity of crashes for human drivers, which we have plenty of research to back that up as well, including a 5-year FHWA study where we really drilled down into the data in a number of states that have implemented 6-inch lines to understand, is there a safety impact? And for those 2-lane type highways, there clearly was a statistically significant benefit to reduce runoff the road crashes using 6-inch lines. So we're pretty confident that moving from a minimum of 4 inches to a standard of 6 inches will help achieve safe deployment of automated vehicles, will help reduce crashes, and will also benefit the robust detection of edge lines for machine vision systems, all 3 of which are going to impact safety in a positive way. Okay, so we'll talk about gaps and weaknesses for a very quick few minutes, and I'm going to turn it over to Jason for some recommendations. So in doing this research, we identified a lot of edge cases that are still out there, and there's lots of different ways to think about and envision how those edge cases might or might not be solved. One of those is through different, different sensor technologies. We've been talking mostly about passive machine vision systems. In other words, the cameras that are in your car that are looking through the windshield. They're pretty low-grade cameras in terms of their resolution. Most of them are still on a grayscale basis. So they're not super fancy cameras like you have in your phone, so keep that in mind. But in addition, we have LiDAR that is being researched and tested, and a lot of the robo-fleets and even automated vehicle heavy trucks use LiDAR. But there's only one vehicle I know of today that you or I can go to the lot and buy that has a LiDAR in it. But even when you start talking about LiDAR, there's at least 3 different versions out there, all falling within the 905 to 1550 nanometer range, which all have significant pros and cons, but still are challenged in fog, rain, snow, just like the passive machine vision systems of today. So there are some potential benefits, though, and we think that edge cases will become less and less in the future, but right now there's still many edge cases, and driving under high glare conditions during the day and driving under wet night conditions, particularly with roadway lighting, those are significant challenges for machine vision systems of today. So we're still trying to figure out some best practices and standards to develop, just like what's happening in other parts of the automated vehicle world, such as cybersecurity and data security. So on the next slide, I'm going to go over and we'll share with you a couple very specific examples of sensing challenges. So the one thing to be clear of, this is when we talk about more uniformity is needed, there's some really good examples in these images here of where, as an infrastructure community, we could probably tighten up our consistency or uniformity standards to provide automated vehicles some accelerated growth potential, because you'll see in these examples, they're generally not an issue for human drivers because we have so much situational awareness, as I've mentioned before. I will mention that all of these images are provided by VSI Labs, which is a sensor testing facility that does a lot of the OEM sensor testing and the Tier 2, Tier 1 sensor testing. And so these guys have a really good understanding of sensors. They also provide AV readiness testing for DOTs. And what you see here is some images of the AV readiness work that they've done around the country for other DOTs. And I'll just start with the bottom left image here. So in all of these, you'll see the predictive path of the car with the green on the left and the red on the white. And this is an example where you're on a freeway without dotted edge line extensions on the exit ramp. And this is a classical case where machine vision systems follow the diverging edge line onto the ramp in the lane line and end up heading straight into the gore area. And this is, there's been at least one fatal crash associated with this type of situation with an automated vehicle, and probably more that haven't been reported. But the MUTCD is trying to fix this by creating a standard right now that would require dotted edge line extensions across these exit ramps so that the machine vision systems would not provide this orientation of a direction straight into the gore. That's one of the changes that we expect in the MUTCD. The next one shows daytime high glare condition. And obviously, we've probably all witnessed this before. In this particular image, we can see the first skip line, but we can't really see beyond that very well. The machine vision system thinks that this four-lane roadway is a two-lane roadway, and is essentially telling the vehicle that this 24-foot wide path is the safe driving path, rather than delineating the green on the white skip line. And then the third case, I felt like I needed to show two images. So here what you have is just your conventional roadway system. I'm not talking about full access control, obviously, but this is, a U.S. route or a state route, you could imagine, with a right turn lane. Obviously, for safety reasons, you want to get that slower moving right turn lane car off the primary travel path. But here, again, you can see the advantage of having the dotted edge line extension through that particular turn lane. On the top image, without it, the vehicle, at least right that particular instance, is sensing a horizontal curve to the right. And obviously, that's not that's not the path of the roadway. And on the bottom, where you have the dotted edge line extension, no problem. The machine vision understands and detects the correct travel lane is straight and not a slight curve to the right. So these are just a few examples I pulled. I work with VSI on a couple of these projects where we do this type of work around the country. We have hundreds and hundreds of examples like this, showing how slight changes to the way we do infrastructure could make a difference in automated vehicle detection and prediction. So these are just some examples I wanted to share with you, focused primarily on pavement markings. The solution for the middle one, by the way, is probably, and we've seen it time and time again with VSI data, is a contrast marking or a black marking which would follow the white skip line. And you'll see that several states are already doing that, but it's not a national standard as of yet. So we know it needs to be done there, and we're working towards that. Okay, Jason, I'm going to go back to mute and turn it over to you for recommendations.
Great. Thanks, Paul. The next section of our presentation, and then we'll provide some time for answering the many questions that have come in through the Q&A and addressing those. Are some recommendations what to do with this information overall. As Paul mentioned during his remarks, upgrading and using enhanced pavement markings are going to be a critical piece of what infrastructure owner-operators can do to help prepare the infrastructure for automated vehicles and also enable their better usage and performance. We highlighted through the study some additional recommendations, especially around design and maintenance standards, developing a strategic investment scenario for physical infrastructure design, including the development of a new design driver that has somewhat different needs than what we have been designing roadways for, especially around some of those edge cases that we've discussed, including the updated and expanded design standards and guidance that are specific to automated vehicles. And the primary solution to this would help ensure that there is uniformity within striping across infrastructure owner-operators, across the states, across the local agencies. That consistency and uniformity has been increasing. However, it is incredibly important for handling some of those edge cases, especially with respect to the striping. We also emphasize that this does have a cost, and several of the questions that have come in during the presentation have focused on those costs and the calculations of them. We do believe that this is the case of where use of performance-based budgeting would be important, linking funding to specific performance measures and performance of those roadway markings. We want to develop and evaluate what those performance standards need to be, as well as increase the available revenue for providing striping and marking on a more regular basis, including the exploration of eligibility for DOT formula and grant funding as it relates to improving the infrastructure and providing for better detection in those machine vision striping programs. To kind of wrap it up and move to the Q&A, we do want to emphasize that pavement markings are critical safety devices for AVs, and they provide co-benefits for both AVs and human drivers, which is a critical piece of this. We're not just recommending a change to pavement markings to support automated driving. This also has substantial benefits for the human driver there as well. There are gaps and weaknesses that we need to continue to explore on the preparation of the infrastructure to support AVs, and I want to emphasize again the needs for updating our standards and providing for uniform design. In a nutshell, that is what we intended to present today on the results of this, and I'm going to open it back up to Morgan or to identify any of the order of the questions that you want us to address. So thank you for your time and attention. My apologies for the beeping on entry and exit. We're going to try to edit that out of the recording on this as well. But we'll turn it back over to you, Morgan, for leading us through the Q&A and finishing up our webinar today.
Yeah, thanks a lot, Jason. That was a great presentation by both of you, and we did get some great questions here. They're still flowing in as I speak. I'm just going to kind of jump around with them and not ask them in particular order unless there's two questions that are kind of related. Main reason I'm doing that is I'm seeing questions both from the chat box and the Q&A box, and they're all kind of jumbled up at this point. So let's see. I will ask first question here from Stan, and it says, is there a metric for pavement marking quality and readily interpretable by AVs? And it's referring to slide 11.
One of the things that we still lack is national standards for testing and validating that different capabilities of automated vehicles and their sensors and how they go about providing solutions. I mean, not everybody does it the same, not every OEM or technology company, and I think that's been a big challenge, but you know, we don't. The answer is no, we don't have anything yet. Now, not to say that there isn't work towards that. You know, the lane keeping tests that are run currently are very easy to pass. They basically require testing in ideal conditions, which is generally on a test track with black pavement and very new pavement marking. Pavement markings. Generally, you know, a tape is used, which provides very high contrast, very high retroreflectivity, and makes the job very easy for machine visions to test, but that's not reality. And so I think there's a lot of interest, and I hear a lot of talk about trying to develop more testing that incorporates the day-to-day conditions of the roadway as opposed to new and ideal conditions that you might only find on a very small percentage of roadways today. But I think that's part of who Jason mentioned at the end of the presentation, some areas for further work, and that's definitely one of them, is to develop some sort of guidance that agencies could use where they would know what thresholds or what are the right metrics to consider for maintenance of road markings to ensure that we have you know, good, robust detection. And that applies to the developers as well. I mean, I think I hear from them that they would like to have a baseline condition to design towards as well. And so I think both sides of the fence, the infrastructure side and the developer side, are interested in that. And I hear more and more talk from NHTSA and really just the USDOT in general about understanding that and trying to support work that's needed to get there. And I know Jason's working on the SAE side of the house. Maybe Jason, you know, there's some discussion of that in what you're hearing. I'll defer to you for that.
Yeah, I think that it's something that, you know, I know that is of interest. I don't have a clear read on developing it yet. I know there's a couple of emerging projects through FHWA and others that, you know, may start refining some of those.
Yeah, for instance, one of the projects that I'm involved with, you know, we are looking at systems similar to what we showed in slide 22 with the VSI images, and then we're also measuring at the same time we do the work with the machine vision systems. At the same exact time, we're measuring the pavement marking characteristics. We're measuring contrast, we're measuring retro, and we're measuring a few other parameters. Some of this stuff we don't currently specify or measure today. We primarily focus on retroreflectivity, and there's almost no daytime metric that agencies use for pavement markings other than presence. But we do know from the testing that's been done, daytime conditions can be just as difficult, if not more difficult, than nighttime conditions. So there may be some need to increase, or develop a metric for daytime in addition to the retroreflectivity metric that we use at night, so that we have a better, so that agencies that are interested in providing guidance can have something to use to know when certain thresholds are being hit where they should consider refurbishing the lines. And then just one other effort that is happening also is there is some work being presented later this year in Europe, where one of the primary differences between what we see as we drive and what a camera sees when they drive is, the camera is a non-biological system, whereas opposed to our eye can do a lot of amazing things that a camera just cannot do. And so when people say, and you'll hear it a lot if you really dig into this space, well, if a human can see it, the camera can see it, or vice versa. That's simply not true. There's a lot of examples where that falls apart. And so there is some very early effort being initiated in Europe where there's interest in developing non-biological conditions for pavement markings that would be more appropriate for machine visions than trying to force the current metrics, which are based on human needs, on a camera system, which has different limitations and different abilities. In one way, we're trying to force a round peg through a square hole when we're setting retroreflectivity standards for machine vision, because it's not the same thing. Retroreflectivity standards were developed the way the eye sees, and the way the eye sees luminance and contrast, not the way cameras see it. So that's a longer road, it's a longer path, but it's probably the more accurate and correct one to take. But that work is just initiating, and who knows how long it's going to take. But in the meantime, I think some basic guidelines using today's retroreflectivity standards and maybe some kind of daytime metric might be appropriate for the machine vision systems.
Haley asks, and I think we might have gotten into this question a little bit during the presentation, but perhaps Paul, you or Jason can elaborate on it. And the question is, are there additional or different infrastructure considerations for sensor types beyond camera and machine vision, such as LiDAR, radar, infrared, and thermal?
I don't want to eat up too much of the time here, but essentially there's definitely work being done in that space. Radar is mostly used for object detection. So in terms of identifying and relying on roadway infrastructure elements, radar isn't necessarily used that often. LiDAR has some potential for different roadway infrastructure elements, but again, it's not really deployed yet, not on a vehicle that we can go buy today, except one particular brand, which is only selling a few thousand a year. It's a startup brand, but no need to mention that, I don't think, on the webinar. Who knows if they'll be still selling cars 2 years from now. But so right now there's not LiDAR being deployed on a vehicle that we can go buy, and there's a big question mark as to whether it ever will be. But there's a lot of asset management efforts that use LiDAR to collect a lot of information about roadway elements, and so there is some potential marriage there, and it's been explored several times, at least for signs, for pavement markings, and for other roadway elements that I've seen, but it just hasn't been commercialized yet in the automotive fleet, I think, enough for people to really start to develop better understandings, whereas, just to put it in reference, the first machine vision system was deployed in 2004 in the U.S., the first vehicle you could buy with machine vision system. So we've had that technology in our vehicles for almost 20 years, whereas LiDAR is still pending. Thermal imagery has a lot of advantages, still pending. So I think until we start to see what those sensors can do and better understand their limitations, we just don't have a full understanding yet to answer the type of questions that you just read, Morgan. I can't remember who authored that question, but I don't think we're there quite yet.
Brian asked, regarding the lane marking corrections for heterogeneity, did you conduct cost estimates? He says, I would expect these to be much more extensive than the width of the striking issue.
Yeah, certainly to get to heterogeneity, we would have to look at a much broader set. We made some estimates of where the states are using certain applications, like marked score areas or dotted edge lines, guidance like shown on the slides that Paul had, but we did not do an assessment of all of the variety of differing markings across the system.
Great. Okay. So we have another question from Jamie, and they ask, does the cost analysis include state maintenance staff labor costs to apply markings more frequently? So I guess the way I would interpret that is, in the cost analysis, Jason, did you guys take into the account, like state force labor costs to apply pavement markings on a more frequent basis than they, perhaps currently are?
I can answer that one, Jason, since I did that piece of the research. I don't think the changes that we talked about imply that you would have to restripe more frequently. It was just what we were trying to do was assess what it would take to go from 4 to 6 inch pavement markings for those states that haven't already adopted 6. And those costs vary by obviously the amount of roadways that those states maintain, but also what materials they use and whether it's state forces or contract forces that they rely on to do most of their markings. But as far as frequency, I don't think and personally feel there's any reason to imply from what we presented that you would have to restripe more often than you currently are, unless you completely change your pavement marking program to some other material. But if you keep everything basically as it is in your state that uses 4 or an agency that uses 4 and you need to move to 6, we were trying to assess those costs. Again, I don't think there would be a change in how often you restripe them, unless I misunderstand the question.
Yeah. Okay. No, I think that's a good answer, at least how I interpreted the question. Thank you. Thank you, Paul. Okay. Well, another question from Joe asks, is the current retro standard that is being implemented nationwide enough for machine vision / lane keeping assist? Should standards be more stringent to enable vehicle sensors?
I'll take a first crack at that, and Jason, if you have anything to add, that'd be great. But right now, those current retro standards, as I mentioned, were developed for older drivers and older drivers driving at night. They had nothing to do with machine vision or lane departure warning or lane keep assist. The second part of the question, I truly feel has yet to be answered. Now, there is work to try to develop some guidance on retro for machine vision and lane keep assist, but I don't feel like we have enough consensus on whether or not that would be more stringent than the older driver retro standards, or the older driver standard retros would be adequate for machine vision. I don't think there's enough research results out there to develop a consensus to answer that question quite yet.
Right. Did you have a follow-up to that, Jason?
Yeah, I mean, I think Paul's absolutely right that I don't think there's enough consensus there, and the current standards, you know, as he described too, were not built around this design driver. They were presented for a different use.
Great. And Jason, just as a time check, I'm sorry, I forgot that. Is this, do we have an hour and 15 minutes for this webinar, or an hour and a half, just for timekeeping purposes for these questions here?
Yeah, I mean, I'm available to stay till the 90 minutes I think we had originally programmed it at 75.
Okay, great. We'll just keep going here then. This question's from Andres, and they ask, is there talk of passing striping costs on to manufacturers, such as per vehicle sold type of cost? And they add, I hate to use the word tax, but here we are. You know, yeah, that's a really interesting question. You know, from my perspective, I haven't heard any talk of passing, you know, these potential additional costs on to manufacturers. But Jason, Paul, maybe you guys have heard different. I don't know.
I have not. I do think it's certainly something that could be in the discussion sort of items, but I don't think that would have a lot of legs yet to get a cohort behind supporting that.
Mm-hmm. Yeah, and I haven't either, other than prior to the infrastructure, the IIJ being released, there were some efforts, there were some bills being proposed that would set aside specific money for AV readiness of roadways. And not to say that they weren't good ideas. Maybe somebody would read them and say they were half-baked. I don't know. But there were people looking at something, at least some set aside in the IIJA. Obviously didn't happen, but I wouldn't be surprised if at some point in the future there is, whether it's a tax, like you said, or a set aside in some next revision of an infrastructure bill, kind of like there is for EV infrastructure today. That wouldn't be out of the question, in my personal opinion. And I saw another question in here about, you know, is there any funding available for small agencies? One of the things to keep in mind is there's some limitations, or there's some exemptions from what FHWA is proposing in this next MUTCD for these 6-inch lines. And a lot of it comes into play for low volume roads in urban areas. So we didn't get into all the details of what's been proposed in the MUTCD, but if you look that information up, you'll see that if you're a small agency, there's probably not much to be concerned about here. This is mostly going to impact state DOTs and toll authorities and those operating heavy volume, high-speed roadways.
Right. see. Okay, here's one from Greg. Are there any efforts to explore, quote, sensor-friendly, unquote, roadways? And that's where stationary objects such as bridge abutments have passive devices like a corner reflector attached to them so that vehicles know to avoid them. Yeah, maybe.
Yeah, there are some, certainly some applications looking at, reading road signs or interpreting other roadway features. I do think that the roadway classification work and the framework efforts that FHWA is about to embark on can probably factor in some of those types of elements, but I'm not aware of any standards efforts right now that are looking to affix different reflectors or markings of some kind to categorize roadway furniture like that. Paul, are you aware of any, or there may be others on the call that might also have more information on that, but I'm not aware of efforts right now.
The one thing that I could think of is there is a group out there that is trying to develop some radar-specific reflectors that could be used for a variety of solutions. That might be one of them. They're very specific to the radar wavelength and wouldn't interfere necessarily with other types of retroreflectors that are out there for the human eye. But then you'd have to basically share that with every provider, every technology provider, so that they would be able to develop the AI and the software to understand it, recognize it, and know what to do with it. And then obviously the maintenance of it you'd have to look at the maintenance of it. If somebody hits it's not uncommon for somebody to hit a guardrail attenuator or a bridge abutment, knock out that reflector, or whatever it might be on there. Not a bad idea. Probably some work going on like that somewhere. The only one I know of is specifically that could maybe fall in that category is a group developing a very specific reflector for radar only. But I know there's others, I know, there's a whole, discussion and even companies that are promoting, special use AV lane, exclusive AV lanes. And I haven't dug deep into that, but there might be some features like that on those. They're kind of like HOV lanes of 20 years ago or today, I guess. But they would be specifically set aside for AV or ADS purposes. Maybe there's some ideas like that are, incorporated into those plans. Maybe, I don't know, just a thought.
Great. Thank you, both of you. For the next question, I'm going to kind of merge two or three kind of similar questions from the audience into one. I hope I don't butcher it too bad, but it has to do with the notion of, this idea of wider edge line lanes working better, 6-inch versus 4-inch. But here's one of the questions here. Have any surveys or studies been done you know, with AV developers or otherwise that confirm the need for 6-inch versus 4-inch stripe. You know, have the AV developers, manufacturers ever made a formal request for that? So we
yeah. So one of the efforts that we did as we were helping FHWA prepare for the next MUTCD, or the one that is pending right now, is we held workshops with machine vision providers from around the country. And a lot of what you see in the manual came out of the series of workshops with those folks in terms of what can we be doing to with the infrastructure to support this. And a lot of the stuff didn't make the final cut because it was very specific to machine vision systems, but it wouldn't necessarily provide any additional safety for human drivers. So we took this to, we took all that information to what's called the National Committee on Uniform Traffic Control Devices, where we have a joint task force set up of all the technical committees. And we would go through the results of this, and there's a lot of practitioners on that, a lot of traffic engineers, maintenance folks, that kind of stuff, to try to filter through what was practical and what wasn't. And then, of course, it goes through some additional vetting through AASHTO and ITE, and all, I think there's 20 or so sponsors of the National Committee, all have a say before it becomes a formal recommendation for the MUTCD. So we did have a lot of those meetings with the machine vision providers, and brought that information back to National Committee, vetted it with practitioners from around the country, and then eventually through agencies and organizations like ITE and AASHTO and APWA, and like I said, there's 20 or so, before it ever made its way as a formal recommendation to Federal Highway. So yeah, we definitely did a lot of that, and we continue to do that. We continue to engage and continue to try to understand what else could we be doing with the infrastructure that makes sense given the timing of how long it takes to change the infrastructure versus the timing of the automotive industry, and marry those two in a practical way, which can be difficult. So, but the answer is long-winded, but the simple answer is yes, we have done that, and we continue to do that.
Great. All right. Here's a question from Bar Rodwaj. I'm sorry, I probably completely butchered that name, but they ask, is there a mechanism where if an autonomous vehicle has learned a new correct behavior, it can be shared across all the autonomous vehicles in operation across the U.S.? Yeah. That sounds to me like a network level connected vehicle kind of question, right? But it'd be interesting to hear what you guys have to say on that.
And I think that's the vision for what would be expected when a nationwide fleet is out there, that there is learning based and those things are shared. Right now there's only theoretical sort of setups, and maybe some of the existing test deployment fleets process that information on a nightly basis for the edge cases that some of those pilot deployments have used, but I'm not aware of anything that's being set up as a formal standard or anything to share across the fleet like that.
Mm-hmm. I haven't either, but I was on a webinar 1 or 2 weeks ago, and there was somebody from the AV Pooled Fund study. I think they were with Drive Ohio, and they were talking about setting up some kind of national depository of edge cases and other information related to automated vehicle deployment. And I think the idea was, at least from my interpretation, I didn't ask any questions, but I just was listening in. I think the idea was generally where this question is going is having sort of a nationwide clearinghouse of issues that anybody could have access to help move the needle a little bit as a way to provide some engagement in a space where engagement is quite difficult because of competitive reasons on the automotive side. So I thought that was a pretty good idea. Where it stands and when it will be implemented, I didn't get a good sense of that, but I do think there's something coming. Oh, so I see a reference from Nick here, accelerateav.org. Okay, so I think I'm probably half speaking the truth from what I remember, because it has been a couple of weeks, but yeah, that seems like the right spot. So maybe check that website out. It comes live June 15th. Okay, thanks, Nick.
Great.
Okay, we only have traction.
Go ahead.
Would you want to maybe do one more, or do you want?
Yeah. I was going to say we have time for one more question, and I found one here that's, a real interesting kind of basic question, but I think it's an important one, and maybe we can wrap up over the next minute or so with that. But Mohammed Reza asks, how cooperative are the automakers in these processes? Which to me, how cooperative, how well are the automakers playing in sandbox together with these automated vehicle technologies and processes? So,
Morgan, until you added that clarification to say how nicely they're playing together with each other, I was ready to answer, because they did talk with us. They were willing to share projections. They were willing to expand on a basic level of some of the discussion, and there has been an ongoing it's a ebb and flow, I think, in some sense, of whether manufacturers say to the government, like, entirely we don't need any infrastructure to advance automated vehicles, or hey, maybe some of these things will help us in the development of them. And I think that we've kind of honed in on the one area that's been very obvious to that discussion is the pavement markings have been a request, and as we talked about in some of the other questions, there is an interest in that. I think it also says the co-benefit on the safety side, so there's a government interest as well in advancing that. But I think working together, there are some convening forums, and we mentioned the SAE, on-road automated driving committee, the infrastructure needs task force. There are multiple representatives on that, so they are working together through the trade association, certainly.
Yeah, great. Okay. Well, that's all the time we have for question and answer. I mean, this has been a great session and lots of interest in it. Jason or Paul, would you like to have any closing comments before I wrap this up?
Sure. I can just start with a couple of administrative things, Morgan, and maybe you were going to go down this path too. But we do have all the questions. We will try to respond to the ones that we didn't address in this webinar as well. The slides and the recording of this will be made available. They'll have to clear the internal FHWA processes for accessibility and all of that, but we will make those available. I know several people have asked if the slide deck would be available, and those will be put out at a later date once the recording and everything is all finalized.
Yep.
I wanted to just say thanks for the opportunity to present on this. It's certainly a body of work that will continue to evolve as technology and policy changes come in, and we'd be happy to stay in touch as we go forward on these topics.
Yeah, certainly. So you see my contact information there. If you'd like me to forward along any questions or comments to Paul or Jason, or really anything research and development related in this space, just shoot me an email or give me a call. I'd be happy to help you out. So with that, we'll conclude this webinar. It's been a good one, I think, and I want to thank everybody for your interest and in joining us today. And thanks, Jason, for taking care of those administrative issues at the end there. Yeah, we'll have the material from this webinar available once it clears our internal processes at FHWA. So with that, good afternoon and have a good evening, and thanks again for joining us. Bye now.